Hello, everyone. We'll be discussing transition metals today in preparation for the lab. Just a little bit about the theoretical background of what you're doing in this lab. We're looking at how different ligands will behave in the presence of transition metal ions. So I'm just showing here a picture again of a complex ion where you have a central metal ion surrounded by several things that are donating electrons to it in order to stabilize its positive charge. What we'll be changing through this lab is what are the things present that are the ligands. So we'll be adding chemicals to replace a given ligand. In this case, we're showing ammonia as a ligand. We could have water, we could have chloride, we could have a lot of different things behaving as ligands. So we'll be looking at how that occurs. We'll also be looking at forming compounds that are not existing as ions and making comparisons. So you'll be preparing a series of test tubes with solutions of these ionochromic compounds, and then you'll be adding chemicals and observing the results as you do that. What you're looking for as you add chemicals is a color change. This is indicating the formation of a different complex ion. So you will be starting with some complex ion, probably with water, and then you might have a color associated with that. And as you add other chemicals, if you see a color change, what that means is that you're adding something that is replacing the water as a ligand, and you observe that with the color change. If you see something that is grainy or opaque, that is indicating the formation of a precipitate. So what that's telling you is that the complex ion you had before adding that is less stable than the precipitate form. So it is a weaker complex ion. If you add something that might form a precipitate to a solution and it doesn't form a precipitate, that is indicating that you have a stronger bond in that complex ion than you had in the one that would lead to the formation of a precipitate. A little bit about how to analyze the data for this lab. You'll write the formulas of all the complex ions that you form. In order to do this, we'll make a few assumptions about coordination numbers, so you wouldn't necessarily know this ahead of time, what coordination numbers you have. If you have a copper ion, a copper +2 ion, assume the coordination number is 4. And if you have any other metal ion, assume a coordination number of 6. So again, coordination number is telling you how many ligands are bonded to that central metal. And then to decide on the stabilities of various complex ions, what you want to look at is whether or not you formed a precipitate with the hydroxide ion. If you formed a precipitate with the hydroxide ion, what that means is that that complex ion is less stable than the hydroxide precipitate. Whereas if another complex ion did not form that precipitate, it is more stable than the precipitate, and therefore more stable than the one that did form the precipitate when the hydroxide was added. So you'll be doing that comparison between various complex ions and whether or not a precipitate forms in order to make that decision. Okay, there's a few things we will be doing a little bit different for this lab compared to how it was written, mostly for safety reasons, but then also a few for based on what chemicals we have available. We are not using potassium cyanide. Cyanide is poisonous, and if it gets into an acid, it could turn into a poisonous gas, and it's potentially lethal. So there's really not a reason to take a risk with that. So we're not going to use potassium cyanide for this lab. We'll not be using the sodium sulfide. It's potential that not, a health risk per se, but it is kind of stinky. So to just avoid that, we will be skipping that as well. And then we will be using EDTA instead of the ethylene diamine. Basically just because that's what we have available. So those three changes, so two things we're not using, and then one substitution there. So just make those notes in your lab notebook as you are preparing for the lab. Couple of things to be aware of in terms of safety. So the concentrated hydrochloric acid is, of course, corrosive. So be very careful with handling that. The ammonia has a very unpleasant odor. So you might want to use the fume hoods while you're using that, or at the very least, just be very careful not to inhale directly from a container that has that present. And then dispose of basically everything today in the container provided. Nothing goes down the drain today. This is partly, actually mostly due to the fact that we are using transition metals, and we need to make sure that we are disposing of those correctly. So to wrap up, a few things you need to do to prepare for this and to complete it. Before coming to lab, make sure to complete your lab notebook with all the procedures you'll be doing, and then take the pre-lab quiz on Canvas, where you'll be uploading your pre-lab and answering a few additional questions about the lab. During the time we are together in lab, you'll be making observations on the complex ion colors and the effect of the addition of the sodium hydroxide. So just observe what colors you see and if you have a precipitate when you add sodium hydroxide or not. During this time, we'll also be checking out of the lab drawers. So we're also kind of cutting back on some of the things we're doing in the lab to give you the time to do that in terms of using, for example, the sodium sulfide. So make sure you get all of that done. And then after you have completed the lab, go ahead and complete the data table, so you don't have to do that during the lab time. You can do that on your own time. And then what you'll be doing is the formulas of the compound, complex ions, and the summary tables of what happens when you add the sodium hydroxide. And then from those summary tables, getting at understanding which of these complex ions are more stable. There are some post-lab questions as well. Make sure to answer those. And then when you're done with the whole thing, you'll be uploading that to Canvas. You have a little bit of time, I think about a week to complete this. So you have some time. If you do have questions, I can help with those if you need a bit more time. So that is the pre-lab for the Transition Metals Lab.